Welcome to clickmyproject.com. Now I am going to explain the coordinated control of a DC and voltage control devices using a dynamic programming algorithm. Now I am going to explain the concept of this processor. Using dynamic programming algorithm, we have to reduce the power loss. So new control method in which a distributed generator, that is DC, actively participates in steady state voltage control together with an underload tap changer ULTC and shunt capacitors SHCS to decrease the number of switching device operations as well as to reduce the power loss in the distribution lines while maintaining the grid voltage within the allowed range. This is the flow diagram for coordinated control of a DC and voltage control devices using a dynamic programming algorithm. First start the process, then next go to the objective functions. Here we choose the objective function as for the maximization problem and also the optimization problem, and next we go to the ULTC, that is underload tap changer. A tap changer is a connection point selection mechanism along a power transformer winding that allows a variable number of turns to be selected in discrete steps. A transformer with a variable number of turns to be selected in discrete steps. A transformer with a variable runs ratio is produced, enabling stepped voltage regulation of the output. The tap selection may be made via an automatic or manual tap changer mechanism. Then taps on transformer permit transformer to be adjusted in field to accommodate variations in tape voltages. A voltage regulator is a tape changing underload transformer with built-in voltage sensing security that automatically changes taps to the preserved system voltage constant. Then next one is the shunt capacitors. What is the result we get from the ULTS? That is directly pass into the shunt capacitor technique. A shunt capacitor means is nothing but a capacitor or group of capacitors which are placed across electric power line or electric appliance to provide a voltage increase or to improve the power factor of the circuit. A switchable shunt may be disconnected from the circuit when conditions warrant, while a fixed shunt is permanently connected to the power line. Shunt capacitor banks are mainly installed to provide capacitive reactive compensation or power factor correction. They are installed near the load terminals in factory substations in the receiving to provide leading volt ampere reactive. Then next step is the dynamic programming step. Here we are going to apply the dynamic programming algorithm for objective function problem and also to minimize the power loss. The DP is a method for solving complex problems by breaking them down into simpler sub-problems. Dynamic programming algorithms are used for optimization. For example, finding the shortest path between two points or the fastest way to multiply many matrices. A dynamic programming algorithm will examine all possible ways to solve the problem and will pick the best solution. Therefore, we can roughly think of dynamic programming as an intelligent brute force method that enables us to go through all possible solutions to pick the best one. Then next step is if the dynamic programming is applied, then get the optimal solution. If we didn't get any optimal solution, then go to the first objective function process. Let's discuss about the implementation work of this process. These are the function files used for this process. dp.va.m is the main function file and the other are the sub-function files. Click that and choose the run file option. These are the results get from our processor. First, in this first current processing, that is how many units are used, that is how many generators are used here, and separately displayed for each hour. And then next one is the hourly results, that is for this denotes that for every hour what is the power demand, total generation, and minimum maximum watt, setup cost, production cost, fuel cost, state, and how the units are on and off condition, and how it works. Then the process running time is totally have 0.0420 seconds, and the process running time is 0.0420 seconds. Then we know then we find also the megawatt values and the cost values. From this we minimize the power loss. Finally, we conclude that the power loss is reduced and also reduce the number of switching operations. Thank you.